want to use an example here whereby I'm going to measure. I'm measuring my groups here, male and females. Then the classifications here, I'm having graduates, also non-graduates, and then those who are not classified, unclassified. Now this is what I was talking about, classifications. The rows represents classifications, the columns represent the groups. In each case here I have two groups, the males and females. So in my groups here I will be having my subtotals here, which are the marginal totals, and then I will have my capital N, which is the overall total for the whole data. And therefore the graduated male are 18, non-graduates are 34, those who are not classified are 8, the total should be 60. For females, I have graduated females are 26, the non-graduated are 22, and those who are not classified are 5. The total should be 50. Or should this be 53? Then when I check the total, the marginal total across the rows, this should be 44, this should be 56, this should be 13, and overall total should be 113. So this is my contingency table. I want to calculate the expected marginals. Now, how would we get the expected marginals? As I said earlier, the expected marginals, we get the marginal totals representing the particular cell and the other marginal total. Then we multiply the two and divide by the total. This will be the expected for this one will be 44 times 60 divided by 113. 44 times 60 divided by 113, and this should be 23.4. When you calculate your margin expectation for this one, you'll find that we are having 44 times 53, which is 44 times 53 over 113, which should give us 20.6. When you continue calculating, you realize that you have 29.7, 26.3, 6.9, and 6.1. Those are the expected marginals. Let us now find and try to test our hypothesis. Now remember our formula was chi-square. Our degrees of freedom in this case, we have rows are 3, while our columns or groups are only 2, males and females. So our chi-square is given by 3 minus 1 times 2 minus 1, which is 2. So our chi-square has 2 degrees of freedom. Therefore, we'll be comparing our calculated chi-square value with a tabulated value and see if we should reject our null hypothesis or we are not going to reject it. Remember, we don't accept an hypothesis. It's either we reject or fail to reject an hypothesis. Now, our formula for the chi-square is given by summation from r equals to 1 to r, and then summation from j equals to 1 to k, observation or high j minus expected value high j, all this squared times expected value ij, which are marginal expectations. Remember, we got our marginal expectations from our contingency table, and therefore using the same, you realize that we have 18 for the first cell, 18.23.4, all this squared over 23.4. Then we had it. Remember, we are doing summation all over. So the next will be that 4 minus 29.7, all this squared, over 29.7 plus 8 minus 6.9, all this squared, over 6.9 plus all the way to the last one, which will be 5 minus 6.1, all this squared, over 6.1. On calculating this, you realize that you are going to get 4.33. So now our chi-square value in this case will be given by 4.33. Now I was trying to test my hypothesis at a 9% significant level. That is my level of significance, and when I check from my table, this is my chi-square, 2 degrees of freedom. So when I check from my table a chi-square of 2 degrees of freedom and 99% significance level, this should be given as 1.39, if I'm right. So when do we reject a null hypothesis when doing a chi-square test? Now that our observed value from my table is 1.39, while my calculated one is 4.33. At this level, I reject my null hypothesis because this one is greater than this one. What do I mean? My calculated chi-square, which is 4.33, is strictly greater than 1.39, and therefore I reject my claim that there is no difference, and I say there is difference. Thank you for watching.